Hello everyone. Today we are back for our daily question. It's pretty hot today, which is why the fan is on. You might hear a noise because of that, but it's fine, I guess. Okay, let's look at the question. What does the question say? Maximum product of two elements in an array. Okay, for a change, I have not solved this question before. This is the first time I'm seeing this question. Sorry about that. Okay, given the array of integer nums, you will choose two different indices I and j of that array. Okay, return the maximum value of nums of I minus 1 into nums of j minus 1. Interesting. Okay, let's just open Xcali. You will choose two indices I and j which are different. First of all, different indices, and then you will take that index value minus 1, the value at that index minus 1 into the value of other index minus 1. Let's have a look at the constraints as well. So up to 500 and nums of I is up to 10 power 3. So because the constraint is very less, the first solution, very naive solution, is of course to just run a double loop. I'm just doing this for the sake of what is the value? 1 to 10 power 3, no? So let's take it as 0, and max answer is equal to max of max answer comma nums of I minus 1 into nums of j minus 1, and then finally we'll go ahead and say return max answer. I don't see why this would fail. And our question is done for this part of it. Thank you for coming. Okay, let's actually try to solve this in a better approach. Let's take an example, right? Let's take this is a very simplistic example, right? 5 to 4. I'll just take the maximum two values and I'll do this minus 1, which is 3, into this minus 1, which is 4. 3 into 4 will give me 12. Same thing here. I will take these two numbers and 4 into 4 will get me 16. Same thing here. 2 into 6 will get me 12. The problem here wait, because so what I was actually thinking, right? So I was thinking of cases like let's say you have something like this. Okay. You know what, let's actually not add 3 5 7 and all. Let's just add 1 1. Okay, now if I take the highest two values, okay, let's add negatives. Let's add minus 2 minus 3. Okay, now if I take the highest two values, my answer will come out as 1. But if I take the lowest two values, my answer will be minus 3 into minus 4, which is 12. So this is my answer in this case, right? But turns out the negative numbers are not allowed in this case. So I guess I can simply take the largest two numbers. So I can say largest is equal to 0 and second largest is equal to 0 as well. And for int I belongs to numbers, if larger is greater than or equal to if I is greater than or equivalent to the largest number, I will go ahead and say largest, or rather let's first assign second largest to we'll assign largest to second largest, and then we'll go ahead and say largest is equal to I. And else if I is greater than the second largest but it is not greater than the largest, then just second largest will update and we'll move on and return largest minus 1 into second largest minus 1. I don't see why this should not work. And that works, and this works as well. Okay, so if you look at the difference, not much of a difference in the runtime, interestingly. I'm guessing because it's just 10 power 5. Sorry, 10 power 5 नहीं, क्या बोल रहा हूँ मैं, 500 elements, so that's 2500 n square is 2500. Factor of 5, increase by a factor of 5, right? So that's why I'm guessing it's not much. So here's the thing about time complexity, right? So if you have your array, if your array size is 10 power 5 versus if your array size is 500, so if you look at n square complexity, so if you have O of n square here, then this will be 10 power 10 operations. But here if you take n square operations, that's 25,000,000, right? So that's 250,000 operations. Here it's 10 power 5. So if you take a factor, right, so that this increased by what factor? So this increased by a factor of 10 power 5. But if you take a factor out here, this increased by a factor of what? 500, right? So this increased by a factor of 500, this increased by a factor of 10 power 5. So like 2, 3, 4, 5 but 500, this gets you like 200 times the factor increased by a factor of 200 times. So that's the essential thing, right? So that's why like n square is very bad when the n is 10 power 5, but it's fine when it's 500. I mean, you won't see much of a time complexity difference is what I deduce out of this. So yeah, thank you for coming. I'll see you tomorrow.